Welcome to Trigonometric Functions with Mrs. Venti. In this video, we're going to look at a function. A function is a graph. A function is a relationship between x's and y's. We're going to look at trigonometric functions, meaning we're going to look at your trig ratios, sine, cos, and tan. And we're going to write it as an equation. For example, y equals sine of theta, or the f of x equals cos of theta. Now, on this slide, we are only going to look at the straightforward sine, cos, tan with no modifications. On the top left, we have a table. This table indicates period, amplitude, and range. Our sine graph is going to be in orange, cos in green, and tan in purple. Then below that, we've got our orange, green, and purple tables in which we have an x input and a y output. And on the right hand side, we have our Cartesian plane, and we've got an x-axis in degrees, jumping 90, jumping 180, jumping 270, and jumping 360 degrees on the x-axis. On the y-axis, we need to insert our values. I'm simply going to go in terms of 1, 2, 3, 4, -1, -2, -3, and -4. And obviously, where they intersect, it's 0 on the y-axis and 0 degrees on the x-axis. So let's get started. In order for you to plot anything on a Cartesian plane, you need an x and a y value. In this instance, your x value is going to be something degrees, which you're going to read from the Cartesian. And your y value is going to be the answer to the equation, which you're going to get from the tables on the left. So let's start with our first one, which is going to be the sine of theta. So what you're going to do is you're going to use your calculator, and you are going to input, or let's do the equations. So I'd like you to do 5 equations. These 5 equations correspond to these 5 degrees in our orange table. So you're going to say the function of sine of 0 degrees, sine of 90 degrees, sine of 180, sine of 270, and sine of 360 degrees. When you input this into your calculator, you're going to say sine of 0 degrees, and you're going to get an answer, which is 0. Sine of 90 degrees is going to be +1. Sine of 180 is 0. Sine of 270 is -1. And sine of 360 degrees is 0. So if I take this information, I put it in the table. My y values are 0, 1, 0, -1, 0. The next step on the sine graph is to plot the points. So in this instance, I take my values like that. At 0 degrees, y is 0. So that goes over there. At 90 degrees, y is 1. At 180 degrees, y is 0. At 270 degrees, y is -1. At 360 degrees, y is 0. I can now connect my dots, and I have a basic sketch of y equals sine of theta. Now I follow the procedure with the cos graph, so you can rewrite the 5 equations again using cos instead of sine. F of x equals cos of 0 degrees, and you will get the following results. So cos of 0 is 1, cos of 90 is 0, cos of 180 is -1, cos of 270 is 0, and cos of 360 is +1. Now I'm going to go ahead and plot these. 0, 1, 90, 0, 180, -1, 270, 0, 360, 1. Then I connect the dots, and I have got the cos of theta graph. The third one we're going to do is the tan of theta. So notice I have double the number of items in the table. So when I go through the equations one by one. It's not going to be 5, it's going to be more than 5 this time. It's going to be 10. The results that I get is this. 10 of 0 is 0. 10 of 45 is 1. 10 of 90 will give you an error message because this is undefined. The reason why this is undefined is because this is an asymptote. So if you have an asymptote, and if you remember, an asymptote is a line that your graph tends toward but never touches, which means that 10 of 90 does not exist, but 10 of 89,999999999, however many you want to do, does exist. And it gets closer and closer and closer to 90 degrees, but it will never touch 90. Next up, we have 135. It's going to be negative 1. 180 is 0. 225 is positive 1. And then you are going to have an asymptote. So 270 is going to be your next asymptote. 315 is negative 1. 360 is 0. So let's plot this one. We'll start with 0, then 1, asymptote. Then we're going to go negative 1, 0, 1, asymptote. And again, negative 1, 0. To sketch this graph, you are going to draw it like this. And like that. So these are the 3 basic trigonometric functions. Y equals sine of theta, y equals cos of theta, and y equals tan of theta. Next up, we want to complete the table on the top, which speaks to the period, amplitude, and the range of each graph. Now, first we need to know what they are asking us. The period of the graph is asking us how long does it take, how many degrees does it take for you to complete one full cycle of the graph. In other words, if you follow the graph from the beginning and you complete a cycle, you will stop before you start a next cycle. In other words, nothing is repeated. So on the sine graph, I will start here at 0 degrees. I go up until 90, down until 270, up until 360, and that'll be the start of the next cycle. Therefore, the wavelength of a sine graph is the period of a sine graph is 360 degrees. Every 360 degrees, I'm starting a new sine graph. So at degree 361, I would have started something new, and it is in the next period. For cosine, the same thing. I start at 0, 1. I go down to 180, up to 360, and if I continue, I would start again going down. Therefore, the period of a cosine graph is 360 degrees. The period of a tangent graph, it's easier to see between 90 and 270 because that is a full shape. Between the two asymptotes, it's 180 degrees. But if I went from 0 to asymptote, that's going to be 90 degrees. And then I go from asymptote to 180. Notice that this portion and this portion is from start to start. After 180, I'm starting a second one, and a period is one full cycle. So the period of a tan graph is 180 degrees. Next concept, amplitude. The amplitude of a graph refers to the difference between the maximum and the minimum. Another way that I like to explain it is the amplitude is how high you go from a flat line, which is going to be your x-axis in this case, all the way to the highest point. It's not always going to be the x-axis, but in this case it is. So the amplitude is telling me how high do I go from this 90 degrees all the way up to the 1, and how low do I go from this 270 all the way to negative 1. Now it's easy to see in this graph that the amplitude is 1. the highest height is 1 and the lowest low is -1 or 1 unit, right? But like I said, it won't always be about the x-axis. So there's an equation that we use for this. The equation for amplitude is a half, open bracket, the maximum of y minus the minimum of y. So if we use the example that we have on the screen for sine, we will say a half, the maximum of y is 1, so a half of 1 minus the minimum of y is -1, and that gives me a half. 1 minus -1 is 2, because minus and minus is plus, so a half of 2 is 1. If you use this equation, your amplitude answer will always be correct, especially if your graph has moved and it's no longer symmetrical about the x-axis. Okay, so the amplitude for the sine graph is going to be 1. The amplitude for the cosine graph, again, the max is 1 where this green is, and the minimum is -1, so it's the same amplitude of 1. And then the question is, what is the amplitude of a tangent graph? So if you're thinking about the amplitude, you're thinking about how high does your frequency wave go. Unfortunately for the tangent, this isn't a frequency wave, so its height extends. It doesn't come down by the asymptote, meaning that there is no amplitude. Amplitude for tangent is undefined. It does not exist. Last concept I want you to know is the range of the graph. Now the range refers to the y values that are applicable to the graph. If you entered any degree into your equation, let's say this is the highest height for the sine and the cos graph, and this is the lowest low for the sine and the cos graph. It doesn't matter what degrees you put in there, sine of 1,752 million or whatever you want to put in there, you will never get anything higher than 1. You will never get anything less than -1. This means that this section of the graph is not a part of the sine and cos graph, and this section of the graph is not a part of the sine and cos graph. The sine and cos graph lives here between +1 and -1. What this means to me is that my range is going to be from -1 up until +1. This graph sine of theta exists between y is -1 and y is +1. The same applies for the cosine, -1 and +1. Whereas the question is now, what do we do with the tangent? Notice that the tangent graph goes up. So it goes from 0 all the way up to +infinity. And then it comes next to the asymptote at 90. It comes from -infinity, goes all the way to 0 at 180 degrees, and then goes all the way up to +infinity. So the range for the y equals tan of theta. We're going to say y is an element of all real numbers, or you can put it in brackets as -infinity till +infinity. This means that all the numbers are valid for the tan of theta. Okay, so this is your basic sine, cos, tan graph information. The last thing I want to emphasize is this information in these tables here. The pattern for sine, it's 0, 1, 0, minus 1, 0. For cos, it's 1, 0, minus 1, 0, 1. For tan, it's 0, 1, asymptote. Minus 1, 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 0, 1, asymptote. If you memorize these patterns, then your calculations are going to be so much quicker, and it's going to be so much easier for you to do your trig graphs. All right, let's do the next section. The difference now in this trigonometric section is that we are going to look at the graph of y equals sine, cos, or tan, but with an a value in front of it. So this a value in front of it is a coefficient that we're multiplying our graph or our function with. So I want you to be able to tell me what's the period, amplitude, and range of y equals a sine theta, a cos theta, a tan theta. And I'm using 3 samples over here. So first we're going to look at y equals 2 sine of theta. Now we know from our previous video or from our previous page that sine of theta has a specific pattern. Sine of theta would normally be 0, 1, 0, minus 1, 0. So in order for me to be able to complete this table, I can go to my equations page, and instead of having it just as 0 theta, I'm going to put there 2 sine of theta, 2 sine, 2 sine, 2 sine, and 2 sine. This means I'm going to say 2 multiplied by the answer of sine of 0. I already said that's 0. 2 multiplied by the cos of theta is 1. 2 multiplied by 0, 2 multiplied by negative 1, and 2 multiplied by 0. So 2 times 0 is 0. 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times 0 is 0. So on my new table, my values are, what did I do? I said 2 times this 0 gives me 0. 2 times this 1 gives me 2. 2 times 0 gives me 0. 2 times negative 1 gives me negative 2. 2 times 0 gives me 0. So if you memorize these ratios or the values, the pattern, it goes a whole lot quicker. Let's plot the sine of the y equals 2 sine. So it's going to be 0. 90 would normally be 1, but now it's 2. 1, 2, 3, 4, negative 1, negative 2, negative 3, and negative 4. 180 is 0, 270 is negative 2, and there. So this here ends up being the graph for y equals 2 sine theta. I'm going to go ahead and sketch in y equals sine theta just so that you could see what happens. So if we answer the question on terms of period, amplitude, and range, period is from here to here. Period does not change. It's 360 degrees from start to start. Amplitude used to be 1, but now it's 2. Used to be negative 1, but now it's negative 2. So my amplitude has changed. It is double. If I use the equation, I would say half of 2 minus 2. So half of 2 plus 2, half of 4 is 2. And then my range is going to be for which values of y is this valid. That's my highest y, and that's my lowest y. So my range is going to be lowest, negative 2, and highest, positive 2. All right, let's do the same for cosine. The pattern for cosine is 1, 0, negative 1, 0, 1. 2 times 1 is 2. 2 times 0 is 0. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 1 is 2. So now I can plot my points, and I'm going to say 0, 2, 90, 0, 180, negative 2, 270, 0, 360, positive 2. Sketch the graph, and that is what cosine of, oh, I made a mistake. I did 2, but actually the equation says 3. Let's do, so cos of 0 is 1, then 0, negative 1, 0, 1. That's the pattern for cosine. So I'm going to say 3 times 1 is 3. 3 times 0 is 0. 3 times negative 1 is negative 3. 3 times 0 is 0. 3 times 1 is 3. So I now have my coordinates for 3 cos of theta. And I'm plotting them. They look like this: 1, 2, 3, 0, and 3. This. So the green graph answers our question of y equals 3 cos of theta. Our normal cos of theta would look like this. I hope you remember on the yellow one. So let's answer the question when it comes to period, amplitude, and range. Period is going to be from 0 degrees till 0 degrees, going from start, which is here, to start, which is there. Start to start is 360 degrees. Amplitude is going to ask us from the highest to, or the lowest to the highest, highest to the lowest. The highest point of the green graph is here at the number 3. The lowest point is here at negative 3. So my amplitude is halfway between these 6 steps, which is going to be 3. So halfway is 3. Amplitude is 3. And then lastly, we're looking at the range. And our range is again looking at those same y values. So the range excludes everything above and below. The lowest value is negative 3. The highest value is 3. So my range is going to be negative 3, positive 3. Lastly, let's do the tangent graph. So our ratios for tangent, I hope you remember the pattern, is 0, 1, asymptote. Negative 1, 0, 1, asymptote. Negative 1, 0, 1, asymptote. Negative 1, 0, 1, asymptote. And our jump is 45 degrees every time. So we're going to do 2 tan of theta. 2 times 0 is 0. 2 times 1 is 2. Asymptote, we don't do anything. So I'm going to asymptote. Negative 2, 0, positive 2, asymptote. Negative 2, 0, positive 2, asymptote. Let's go ahead and plot this one. So it's going to be 0, 2, asymptote. Negative 2, 0, 2, asymptote. Negative 2, 0, etc. So you draw your graph, it's going to look like this. And then I will also include the normal tangent graph just to show you what it would normally look like if we had not multiplied it by 2. So the yellow is your normal, and you'll notice that if you for example went with 4, if you had 4 tan, then it would look like this. So the higher it becomes, the closer and closer it becomes to becoming sort of like a straight line. I don't know if that makes any sense to you. But this is how the A value changes the tan graph. So, do you remember the period of a tan graph? The period of a tan graph is 180 degrees. From start to start is 180 degrees. Amplitude for tan is undefined, it does not exist. And the range for tan is y is an element of all real numbers. Or you can put it as negative infinity, positive infinity. All right. On this slide, we are going to change our approach. Instead of saying y equals a sine of theta, we are going to say negative a. And we're going to look at what happens to the graph if the coefficient is a negative number. So the first thing we're going to do is -2 sine of theta. Do you remember the ratios or the table values for sine? So it should be 0, 1, 0, -1, 0. So -2 times 0 is 0. -2 times 1 is -2. -2 times 0 is 0. -2 times -1 is +2. And then we have 0. That is the ratio for cos. Let's plot it. So it's 0, -2, 0, +2, 0. This here is our new sine graph. This is our new sine graph. If I draw our normal sine graph, it would look like this. This is what sine would normally look like. So what happens is when you are doing a negative sign in front of your coefficient, the result is what we call a reflection. So where your graph would go up, it now goes down. Where your graph would go down, it now goes up. Let's do the same for the cosine, or let's answer the questions. So the period remains the same. It's from here to here, which is 0 to 360. We're doing the orange graph, by the way. So period is 360. Then we look at the amplitude. Amplitude is going to be, the highest point is 2 and the lowest point is -2. So the amplitude is going to be 2. And the amplitude is determined by the 2 in front of the 2 that is part of the coefficient, and not the negative sign. The negative sign tells us whether it's a reflection or not. Lastly, we want to talk about the range. So the range, the lowest value is -2 and the highest value is +2. Put that in brackets. Let's do the cosine graph. So for the cosine graph, we do our table 1, 0, -1, 0, 1. Multiply that by -3. So -3, 0, +3, 0, -3. Now I'm going to plot it. So 1 becomes -3, then 0, then +3, then 0, then -3. So now my cosine graph looks like this. Instead of what my cosine graph would normally look like is this. So again, what you see is a reflection. When you would normally go down, you go up. And when you would normally go up, you go down. And that is all attributed to that minus sign in front of your coefficient. Let's answer the questions. The period stays the same. It's 360 degrees from start to start. The amplitude, it's going to be, highest point is +3, lowest point is -3. From those 2 points, -3 and +3, it's 6 points, right? So half of 6 is 3. The amplitude is 3. And your range, lowest point is -3, highest point is +3. Lastly, let's do the trigonometric graph. So for trig, we are going to do, tangent, the tangent graph. Let's do our values. It's 0, 1, asymptote, -1, 0, 1, asymptote, -1, 0, 1, asymptote. Now we're going to multiply by -2. So 0, -2, +2, 0, -2, +2, 0, -2. Now we can plot. We start at 0, then we go to -2, asymptote, +2, 0, -2, asymptote, +2, 0, -2, asymptote. if I was to sketch it, I would do that and go up and down and up and down. So that over there is what your trig graph looks like if it is reflected with a negative sign and the a value is 2. Your normal graph would normally look like this. Oopsie. So you can see that where the yellow goes up, the purple goes down. Where the yellow goes down, the purple goes up. So that is your reflection. Let's do period of a tangent graph is from 0 to 180. From start to start, it's still 180 degrees. The amplitude is still undefined, it does not exist, and the range is infinity. Y is an element of all real numbers. Now, what we've learned when we've changed the a value is that the a affects your amplitude. If we go back, we can look at, this is when a is 1. Our period is 360, amplitude is 1, range is -1, 1. For sine, when our amplitude is 2, then our period is 360, amplitude is 2, range is -2, 2. When our amplitude is -2, then our period is 360, amplitude is 2, range is -2, 2. So the a in front of your graph or in front of your ratio is going to change the amplitude only. Period stays the same. So amplitude and range are affected by this a value. Next up, we are going to look at what happens if you have a normal sine cos tan graph, but you add a q at the end. So we're going to follow the same procedure. Let's start by putting in our basic ratios at the bottom. So what's going to happen here? Let's start with the sine graph. We're going to say sine of theta plus 1. Sine of 0 degrees is 0. 0 plus 1 is 1. Sine of 90 is 1. 1 plus 1 is 2. Sine of 180 is 0. 0 plus 1 is 1. Sine of 270 is -1. -1 plus 1 is 0. Sine of 360 is 0. 0 plus 1 is 1. I want to show you what this looks like in the graph as well. This is what a normal sine graph looks like. But now I'm saying 0 plus 1, which means I go 1 up and I start there. 90 is 1 plus 1. I go 1 up. I plot it there. 180 is 0. I go 1 up. 270, 1 up. 360, 1 up. So I still have my sine graph, but the difference now is that my sine graph has moved 1 unit up, and that 1 is ascribed to this 1 in the question. The plus 1 is what we call a vertical shift, and plus means we're going up, whereas minus would mean going down, and the number tells me the number of units I'm going up. So it's the same sine graph, but 1 unit up. Let's do cosine. So cosine, we're going to say -2, cos -2. So 1 minus 2 is going to be -1, and -2, -3, -2, -1. Let's sketch this one. Your normal cosine graph would look like this, but we're not doing a normal one. We're going to do one that's moved 2 units down, right? Down 2. So -1, -2, -3, -1. No, that seems wrong. -2, and then -1. Let's connect the dots. So this is what y equals cos of -2 looks like. Again, from the yellow to the green, you've moved down 2 spaces on every single point that you plot. It's just moved down 2 spaces. Let's do tangent. So tangent, we're going to say plus 2. Plus 2, already you know, vertical shift, plus means up 2 units, right? So where I would start with 0, I'm going to say 0 plus 2 is 2. 1 plus 2 is 3. Undefined is undefined. Minus 1 plus 2 is going to be 1. 0 plus 2 is 2. 1 plus 2 is 3. 1, 2, 3. Okay, so let's plot this one. I'm going to do 0, 2, 1, 3, 45, 3, and asymptote. 135, positive 1, 180, 2, 225, 3, asymptote. Then 1, 2, and the last one would be 3. If I sketch my graph, it'll look like this. And there you go. So I've added the normal tangent graph in yellow so that you're able to compare. And again, what has happened is the 2 points we plot move up 2, from here to here, move up 2. From here to here, move up 2. Here to here, move up 2. Here to here, move up 2. And that's all that we're doing with a vertical shift. You're either moving up or down, however many units. Let's go ahead and answer the questions in the table with regards to the period, amplitude, and range. And then you're going to see what effect does the Q have on period, amplitude, and range. Period of sine is going to go from start to start, and that on the orange graph is still 360. On the green graph, it's still 360. On the purple graph, start to start is still 180 degrees. So period is not affected. Amplitude, so we're going to say amplitude is high minus low. In this instance, it's 2 minus 0. Half of 2 minus 0 is 1, so my amplitude stays 1. So this is the amplitude for sine of theta. Only sine of theta, this plus 1 doesn't change my amplitude. Same thing for cos. I'm going to say half of -1 minus -3. So -1 minus -3 is equal to -1 plus 3 is equal to 4. Half of that is going to be equal to, no, that's incorrect. 3 minus 1 is 2. Is equal to 2. So half of 2 is 1. My amplitude is still 1. Notice the distance here is 1 and the distance there is 1. And then my amplitude for tangent is still undefined. It does not exist. Lastly, the range. On my orange graph, my lowest value here is 0. My highest value is positive 2. On my green graph, my lowest value is -3. And my highest value is -1. On my tangent graph, my range is still going to be y is an element of all real numbers. All right, thank you. I hope this made sense. In this section, we are going to look at what happens if I add a coefficient, and we said that the coefficient changes my amplitude. A negative sign in front of the coefficient gives me a reflection, and we are going to look at what happens if I add Q, so that Q will give me a vertical shift. So this way of writing an equation is what we call standard form. Y equals, say, a sine of theta plus Q. That is the standard form for a trigonometric function. First, I'm going to complete my table. I've inserted the numbers that we've memorized, And now I'm going to do the equation. I'm going to say 2 times 0 is 0. 0 plus 1 is 1. I'm doing this equation. 2 times 1 is 2. 2 plus 1 is 3. 2 times 0 is 0. 0 plus 1 is 1. 2 times negative 1 is negative 2. Negative 2 plus 1 is negative 1. 2 times 0 is 0. 0 plus 1 is 1. I'm going to do the exact same for the rest of them. I'm going to use this one, negative 2 cos theta minus 2. Negative 2 times 1. Negative 2 times 1 is negative 2. Negative 2 is negative 4. 0 minus 2 is negative 2. Minus and minus is plus. 2 times 1 is 2. So 2 minus 2 is 0. 0 minus 2 is minus 2. And minus 2 times 1 is minus 2. Minus 2 minus 2 is minus 4. Next up, let's do the tangent. So we're going to say 2 tan theta plus 1. 0 times 2 is 0. Plus 1 is 1. 1 times 2 is 1. Plus 1 is 2. Minus 1 times 2 is minus 2. Plus 1 is minus 1. 0 plus 1 is 1. And then 2 plus 1 is... No. 2 times 1 is 1. Plus 1 is 2. Minus 1 times 2 is minus 2. Plus 1 is minus 1. And then 0 times 2 is 0. Plus 1 is 1. The last one will give me 2. Now I can plot my graphs. So for the orange graph, I am going to say 1, 3, 1, negative 1, 1. If I sketch my my sine graph, it looks like that. My second one is cosine, so I'm going to do negative 4, negative 2, 0, negative 2, negative 4. So my cosine graph looks like this. And then lastly, I'm going to do the tangent. 0. Oh, not 0, sorry. 1, 2, asymptote. Negative 1, 1, 2. There's something wrong here. And 2, asymptote, negative 1. I have a feeling something's wrong here. Okay, so I recognize my mistake. This should be 3, and this should be 3, and this should be 3. Which means over here, we're going to go up to 3, and here we're going to go up to 3. So if I sketch this graph, it's going to look like this, like this, like this, and like this, where my reflective line is actually there and not the y-axis. For both, notice that +1, it's the same for the tangent and the sine graph, whereas for the cosine mark, it's over there. So there we go. Let's answer the question. Period for sine from start to start is 360 degrees. Period for cosine from start to start is 360 degrees. Period for tangent from start to start is 180 degrees. Period does not change. Amplitude for the sine graph is going to be 1, 2, and 1, 2. So amplitude is 2. Amplitude for the cosine graph is going to be 1, 2, 3, 4. Interesting. So I've counted 4 hops, but remember it's half of that. Oh, which means that I've done half of those 4, is going to be 2. Again, why is it 2 on sine and 2 on cos? Because technically on sine it's 4 hops from the highest to the lowest and then half, right? So here we got 4 hops and half is 2. And then amplitude for tangent is undefined. Range is the highest and the lowest. So the highest for sine is 3 and the lowest for sine is -1. So we're going to say -1, 3. For cosine, the highest is 0 and the lowest is -4. So -4, 0. And for tangent, y is an element of all real numbers. All right. So these are the basics of trigonometry. Thank you all for watching, and I wish you all the best. Like and subscribe. Have a great day. Bye-bye.